Now see the example number 1. If L is given as, suppose, 3 plus minus 0.01 meter, then express 3L. So it means now we have to write 3L. So it is nothing. Let y is your 3L and this is nothing. It is similar to L plus L plus L. So here the method is your multiplication of a constant. So if the multiplication of constant comes in the value of L, so that multiplication constant will multiply in the all other term. So y is your 3L is equal to your multiply in this 3 plus minus 0.01 meter. So y will be here 9 plus minus 0.03 meter. In this manner we should express the value of y, or which is equal to your 3L. Now similarly see the another example. The resistance of two wires is given as R1 is equal to, let 4 plus minus 0.2 ohm and R2 is equal to, let 8 plus minus 0.1 ohm. So express the equivalent resistance, when these are connected in series, connected in first part series and second part in parallel. So this is the question here. Now see the how to solve this one. Series combination. As we know, in series R is equal to your R1 plus R2. So this is simple calculation here. So R is equal to your R1 value 4 plus minus 0.2 plus R2 value here 8 plus minus 0.1. So the resultant R will be your 8 plus 4 12 plus minus 0.2 0.1 0.3 ohm. This is the value of R. So this is the case in series. Now come to the in case of parallel. See. So in the second part, when it is in parallel, as we know, 1 by R is your 1 by R1 plus 1 by R2. So now it can be expressed like this. R is your R1 R2 by R1 plus R2. This we can solve by using the differentiation method. See, this we can write log R is here log R1 R2 and minus log R1 plus R2. So after differentiation we will get delta R by R is equal to your delta R1 by R1 plus delta R2 by R2, and for error no negative sign, all positive. So delta R1 plus delta R2 by R1 plus R2. So this is called your maximum error. So, normally we have to calculate the maximum error always. Now, delta R1 by R1, delta R1 here 0.204, 0.2 by 4 plus delta R2 here 0.1 by 8 plus delta R1 plus R2 0.1 plus 0.2 0.3 and R1 plus R2 4 plus 8 12. So, this is equal to here, take LCM here, let 24, 6 into 0.2, 1.2, 0.3 and then 0.6. So, this will be your 2.1 by 24. So, this is the delta R by, so delta R is equal to 2.1 by 24 into R, and into R means here R1 R2 by R1 plus R2. So, 2.1 by 24 R1 R2, R1 into R2, 4 into 8, R is equal to here R1 R2 means 8 into 4, 32 by R1 plus R2, 8 plus 4, 12. Now, we can simplify this one. We can divide by 8, then 4, 3 and 3 here, 0.7 by 3. We can check here 0.7 by 3. Further we can write here 0.2, 3 and 3. This is the value of delta R. So, finally, so R is equal to your resultant R. Resultant R is your R1 R2 by R1 plus R2, R1 R2 by R1 plus R2 plus minus delta R, and R1 R2 by R1 plus R2, that value we can have R1 R2 32 and R1 plus R2 8 plus 4 12 plus minus delta R value we got 0.2, 2, 3 into 3, this is your R, and that we can simplify further. This is 16 by 6, then 8 by 3 plus minus 0.233 or 2.67 plus minus 0.233. This is the value of R. In this manner we can calculate equivalent resistance if it is in the parallel. So, this is the general or basic idea about your error analysis.